Welcome to Math 125, Chapter 4.9 Notes. Today we're going to be talking about antiderivatives. By their name, you can tell that it's the anti of derivative, so the opposite of derivative. But what does that mean? In more formal terms, it means f of x, function f of x, is an antiderivative of g of x if f prime of x is equal to g of x on a given function, on a given interval of x. What does that jargon mean, right? So it means that we can use our prior knowledge of derivatives to find the integral, or sorry, the antiderivatives of a function. I'm getting ahead of myself when I say integrals. So, for example, given g of x equals 2x, is it possible for us to find the antiderivative of it, or f of x, right? Well, yes. We have seen it multiple times. I mean, Math 1.4 was full of derivatives. I'm pretty sure you guys saw this. So we can use the power rule, which is x raised to the power n, and you know that n times x raised to the power n minus 1 is the derivative. And since we know that n is equal to 2 here, we can find one answer, which is equal to x squared. So x squared is the answer, is the antiderivative to x. Now I want you to pause for a second and tell me if I'm right. Is x squared the only possible answer, or just one of the possible answers? I hope you give it a thought and realize that no, f of x is not, or x squared is not the only possible answer, because f of x could also equal x squared plus 1, or x squared plus 80, or x squared plus 10 to the power of 100, right? Any of these values could have been x, any of these values could have been 2x, because when you take the derivative of a constant, you get 0. So how do we get around this? How do we find the antiderivative of 2x, right? What we can do is say that x squared is a specific solution, or a specific antiderivative for 2x. And for a more general solution, the antiderivative of 2x would be x squared plus c. This plus c accounts for all constants that could go there, right? And once we're given more specific values, we can plug that value and figure out what the c value is. All right. So to find this x squared plus c, right, we use the power rule in inverse. Well, good for you, because there is a formula for that. So power rule in inverse, or the power rule antiderivative, is if you're given x raised to the power n, and you want to try to find its antiderivative, the antiderivative would be x raised to the power n plus 1 all divided by n plus 1. We can prove how this works by just finding the derivative of x raised to the power n plus 1 divided by n plus 1. I do the derivative, we get n plus 1 instead of 1 raised to the power x raised to the power n plus 1 minus 1, right? So this cancels with that, and this cancels with that, and we're left with x raised to the power n, which is your solution. So this is an important fact to keep in mind. More importantly, we can use the same thing to find trig values as well. So that if we're given d dx, we know that d dx of sine, the derivative of sine of x plus cosine of x. So if we're given the g value is cosine of x, we can find the antiderivative f of x equaling the sine of x plus c, right? So the basic thing is using the inverse of the derivative, we can find the antiderivative, or going the opposite way, we can find the antiderivative. So here are a few common antiderivatives listed here. Don't worry about the integral sign. We'll go over that later, what the integral means. Some interesting antiderivatives I see are if g of x is equal to e to the x, then the antiderivative is also equal to e to the x plus c, which is consistent with its derivative. Something more interesting, that 1 over x, the antiderivative I would be ln, so the value of x plus c, which I find very interesting. Well, there's a lot more. I would pause the video and take a look, see which ones you find interesting. But often someone now will be using most, if not all of these at some point. All right, let's move on to some other problems that we'll be going today. So the first problem that we're given is we have to find the most general antiderivative of the function f of x equals 3 over 4 plus 2 over 3x squared plus, or sorry, minus 5 over 6x cubed. Right, so the easiest way to do this is to break it into exponents. So the first one would be 3 over 4. Second one would be 2 over 3 squared. And last but not least, the third one would be negative 5 over 6 x to the cube. All right, so it's just about cube. All right, what we can do is write x to the 0 here and use the power rule in reverse, because this one, to solve this problem. What we can do is isolate. We get that, and then use the power rule. So x is plus 1, 0 plus 1, which gives us 3 over 4 times x is equal to 3 over 4. For the second one, same thing. 2 over 3 x squared is x squared. No, n was 0 here. 7. And yes, negative. N is 2 here. So we get x 2 plus 1 all over 2 plus 1, which gives us 2 over 3 x cubed divided by 3, which gives us 2 over 9 x cubed. And now for the third one, you get negative 5 over 6 x cubed, isolate the x cubed, right? And then n is equal to 3, so we get x 3 plus 1, 3 plus 1, and we get negative 5 over 6 x to the 4 over 4, which gives us 5, 24 over x over 4. Sum it all up, the answer would be 3 over 4x plus 2 over 9 x cubed plus negative 5 over 24 x to the 4 plus c, because it wants us to give a most general antiderivative. So we'll use c. They gave us some specific value for f of x, like f of 0 equals 4, then we would know that c is equal to 4. But since we're not given, we have to assume. We have to just give the most standard general formula, which is this. Moving on to a harder problem, we are given that a high-speed bullet train accelerates and deaccelerates at the rate of 10 feet per second. Its maximum cruising speed is 105 miles per hour. Round your answer to the third decimal place. All right. First question is, what is the maximum distance a train can travel? Accelerates from rest until it reaches its cruising speed, and then runs at that speed for 15 minutes. I want you to take some time and do this problem on your own. You can pause the video if you will, or if you're done with that. Let's remember something. So remember that the derivative of distance is equal to the velocity. The derivative of velocity is equal to acceleration. So it goes from here to here, and then here to here. Now we know that the derivative. Now that we know that antiderivatives are the opposite of the derivatives, we can go backwards. So the antiderivative of acceleration is velocity. The antiderivative of velocity is distance. So using that, we can solve for this value. We can solve for the distance. So we're given the acceleration equals 10 feet per second. And now if we take the antiderivative of this, we get e is equal to 0 because we have nothing. So using the same formula from above, p0 plus 1, 0. From above, we get 10p plus c equals to velocity, right? But since it tells us that it's at rest, we know that v of 0 is equal to 0, and s of 0 equals to 0. So the velocity here, since we know that v of 0 equals to 0, then we know that c equals 0. The formula v of t is just 10p. And from velocity, we'll try to find distance. v of t, the velocity formula is 10p. This is squared, so feet per second. And now we have to find the distance. So we'll take the antiderivative of that. So 10p, now we know the n is equal to 1. So we do the same thing, isolate the n plus 1, all of plus 1. Then we take the antiderivative and go from that. So we have 5p plus c equals the s of t. But since we know that, since it's at rest, then we know that s of t, s of 0 equals 0. Then we know that this c is also equal to 0. So c is equal to 0, which means that s of t is equal to just 5t squared. All right. Now for a little bit of more visual, we have to use a cube. So here to here. So the problem says that it accelerates till it reaches its cruising altitude. We use the velocity over time, which is reaches its cruising altitude of 154, and then from there it runs at that speed for 15 minutes. Well, since we're operating in feet per second, let's just convert this distance into feet per second. So 15 times 60 equals to 90 or 900. So this distance is x. This distance is 900 plus x. Well, we can convert this, but we have to find how much time it takes for the train to get to its cruising speed. Since we have the formula for velocity, we can find that if we just use that formula. We know that 154, let's use a different color for this, I guess. Blue. 154 equals 10p. Sorry, not 154. Well, first we have to convert 105 miles per hour into feet per second. So 105 mile hour. And we'll use dimensional analysis for this. We know that 580 feet, mile, and 1 hour has 3,600 seconds. The dimensional analysis gives us 154 feet per second. All right, now we know 154 feet per second equals 10 p. So p is equal to 15.4. So we know this is, get rid of this and this. This is 15.4 and this is 15.4. Right, but what we can do is we can separate these as two different. So we can separate these as two different times. So we have, we'll use a different color. So I guess purple. So now since we're finding two distances, we have distance 1, S1, or D1, I guess. D1, which is here, D1, and this is D2. So D1, which is going to be using this equation. Using this equation, we're going to just use that equation to find the answer. So 15, and this t for this one is going to be from 0 to 15.4. 0 to 15.4 squared. D2, which is a constant velocity, which is 154, is for 15 seconds or 900, or 15 minutes or 900 seconds. So we'll just put 900 here, it's just this distance. which will give us two values, which are, so 5 times 15, sorry, just do this again, 15.4 squared times 5 equals 1185.8, 1185.8. And the second distance value would be 154, which is 900, not 900, which is 138, 600, 138, 600. When we add these two together, 138600 plus 1185.8, we get okay, we get 139785.8, 139.139.785.8. And when this would be our final answer, but since this number is a little bit wrong, let's convert this into miles. So 138, we'll use dimensional analysis again, and we would get times 1 mile is 5280 feet, which gives us this number by 580, gives us 26.475. Which 7? And that's the final answer from the first problem. You know, it must be a little bit jarring looking at how much work you have to do from the first problem, but it's a little bit the difficulty. I don't know. There's another way I want to show you how to do this kinds of problems. So the second part gives you that the train starts at rest, then it comes, and then it must complete a stop in 15 minutes. So what is the maximum distance traveled by the train under these conditions? Well, I want you to, there's another way of thinking about it. You can draw a graph similar to what we drew earlier, which is v of t times t. And so we know that the train accelerates to its cruising altitude, which is 154. Then it stays at that altitude for some time, and then it drops down. And this whole thing happens in 900 seconds. That's in 15 minutes. And since we know that this is 15.4 from the previous problem, we know that this part is going to be 900 times 15.4. So we can use the area of it. So another interesting fact is that the area underneath the velocity curve is the distance. So what we can do is use the distance to find we can find the distance by finding the area underneath this curve. So there are two ways of doing it. You can either separate these into two separate triangles and a big rectangle, or you can use the trapezoid, which is also possible. So I'll be using the trapezoid for this one. The area of a trapezoid is equal to 1/2 base 1 plus base 2 times height. Well, base 1, so the area would be 1/2 base 1, which is 900, plus base 2, which is 900. So this is base 1. Okay, we use it from color. So find the bases, which is this is base 1, and this is base 2. And so it's 900 plus 900. Base 2 would just be well, it would be 900 minus 15.4 minus 15.4, which just gives us minus 30.8. And let's just look at these two. Times the height, which is 154. And this would give us, let's see, 900 plus 900 minus 30.8 times 1 by 4 divided by 2. This is 136,228.4 feet. Well, we're going to divide this by miles, so this would be 5280 feet. Feet cancel, and we're left with 5280. This gives us 25.801 miles. So you can do this in two ways, this way or this way, whichever you fancy. If you find it more intuitive to do it this way, then I would suggest doing it this way, but if you like the area under the curve parts, then I would suggest doing it this way. Moving on to the third problem, we want to find the minimum time it takes the train to travel between two consecutive stations that are 52.5 miles apart. All right, we'll just copy the same things on. So the acceleration is 10 feet per second squared. Cruising altitude, which is v const, is equal to 154 feet per second. So I'm going to use the same, well, I find the area method easy. So I'll be using that. If you look at it this way, the train has to start and reach its cruising altitude, which is 154 feet in 1:15.4 seconds. And then it has to do the same, it has to stop, so it has to do the same thing there. So this is also 15.4 seconds to start and stop. And this is the area it spends in its cruising altitude. We know this total area is going to equal to 52.5 miles, which if you multiply that by 5, sorry, multiply that by 5280 feet, 1 mile you would get 52.5 times 5280, 277, 200, 277, 200 feet. Well, you can already use you can use 2 times 1/2 base times height from the area of these rectangles, and then you just have to, then it won't be as hard. 2 times 15.4 times 154. So this cancels with that, and you're left with 15.4 times 154. You're left with 2,371.6. 2,371.6. And you subtract that from 277, 200 minus 2371.6. This gives you 277, 200 minus 2371.6. It gives you, oops, sorry, 274, 274, 828.4. And that is this area here. Is this value. Well, we know that it's at cruising altitude for that whole point, so we can just use that to find the answers, of course. 28.4 divided by 154 gives us, divided by 154, gives us 1,700, 1,784.6, 1,784.6 seconds. Seconds, and if we convert that into minutes, 60, what do we get? We get 29.473. We get 29.473 minutes. That's how much time it takes for the train to stop between these two tracks. Now, the fourth problem is very similar to the third one, so I will just this problem is a slightly more difficult variation of the other ones. We'll be doing the same thing, I guess. I'm sorry if you preferred the first way we did the problems. You know the time taken. 37.5. 37.5 is the minutes. Now this is 154. We know this is 15.4. This is 15.4. So it's almost very easy now to convert this into seconds. So this would be 37.5 minutes times 60, which gives us 37.5 times 60 gives us 250. Now we can subtract 2250 minus 30.8 minus 30.8 gives us that times 154. So that would this area right here. 2219.2, 2219.2 times 154 equals 134,758.4. 6.8 plus 15.4 times 54, which was 2371.6. And when we add these two up, 341756.8 plus 2371.6 gives us that, and we divide that by 5280. It gives us this equals to 65.17. And we're done. If you have any questions, do let me know. Yeah, I know I didn't cover this method a lot, but I guess this is standard method of doing it. This would be a shortcut. So if you prefer this method, this is the shortcut. This is the long method, and it makes more sense. So if you have any questions, let me know. I'll put my socials in the bio if you're interested. Let me know. Thank you. Have a good day.